Okay, so today we'll be studying relational databases and relational databases. The short form for the relational databases is RDBMS, Relational Database Management System. To understand the relational database management system, we need to understand the database first, right? And to understand the database, we need to understand the data. Data as in normal term, it is raw facts and figures. For example, your name, your class, your roll number, your father's name, your date of birth, individually, these all are raw facts. We can't figure it out what exactly the meaning of all these. For example, Aman. So Aman independently cannot describe anything, right? If I say 12, if I say your date of birth, that cannot describe anything about that, right? But if I just club all these in and process that and then present it, that collection or the processed data is known as information. And we store this information in a database. Database is a broad figure. Within database, we have got tables, and within tables, we store records. And these records are nothing but the information. Okay. So if we talk about the definition, the bookish definition, data can be facts related to any object in consideration. That's the simplest definition of the data. And in other form, data is raw facts and figures. Then I have already talked about this, that age, a video, your other data like your Facebook information, your WhatsApp information, your Twitter, your Instagram, all these are basically the data. And collectively, when you talk about all those, that becomes information. So now that thing comes into the picture, that why basically we need a database. Database, as I have already talked about, that database is a broad figure. Within that we have got tables, right? Initially, when the database, kind of thing was not there in picture, we used to store information in terms of registers. But to store information in registers and to retrieve information to the registers was time-taking process. So what exactly we did? We converted those registers into the databases. Now, to retrieve the information and to store the information was comparatively easy, in that way. But again, later on, we felt it like these informations which we have stored in terms of files, because initially when we converted those register into the databases, the information where we used to store those information were there in terms of files, and there was no concept in which in these multiple files, if we talk about the information which we have stored, there was no concept of connecting these files to retrieve the summarized information. For example, in your case, if you talk about students' information, your classes are stores in your general informations. For example, your basic information stores the school, and then your class teacher stores information of your attendance and his subject. Similarly, the different subject teacher stores information about their subjects, obviously in terms of marks. And later on, the information which everybody has stored about you, activity teachers, your games teachers, your, the subject teachers, your class teachers, everybody has stored information. School has also stored information initially when you are admitted to the school. So later on, we picked up the entire information collectively and placed those information at respective or designated places. And that entire, output that comes out from these, that becomes your report card. That includes everything, your attendance, your marks, your basic information, your photograph, everything. And all this information are stored somewhere else. So what exactly I'm talking about, that the information which you have stored at multiple places, later on, we retrieve those information from those multiple places and present it in a user understandable manner. And that is basically called the report. And in your case, that is called the report card. Initially, combining or connecting these files were not there, and later on they upgraded, and we upgraded basically that database, and now we store information in terms of tables, and all these tables can be connected to each other. All these information can be connected to each other to give you the summarized information. That is why the database is required. so that we can create multiple tables, and those multiple tables can be connected to each other to generate a summarized information or a summarized report. Then it also, I mean, that is the basic thing, like, that why basically we need a database. And these are some examples of the databases we have got. We have got another telephone directory, which stores information about the people, their telephone numbers, sometimes their occupation also, power generation on an hourly basis, or a daily basis, on a weekly basis. And if you just want to later on, generate the reports that what is the progress in terms of power generation on a daily basis, or a weekly basis, or a monthly basis. Similarly, the Facebook stores our information. For example, if you have posted your some photographs or some posts on Facebook, on next year, like, on the same day, it reminds you that this is the post which you have posted on that day. Do you want to again repost it? So anything which you posted, basically that application stores that information somewhere else within the database, and later on it has got an inbuilt concept that it picks up that information from the database and present it to you. If you want to show it, you can show it there. So basically, anything which you want to present, you need to store it. And to store in terms of computers, we need a database. Nowadays, we talk about the ORDBMSs. I'm talking about RDBMS right now, Relational Database Management System. But nowadays, in current scenario, we use ORDBMS. That's the latest term that is used in terms of database. Object-based Relational Database Management System. But right now we'll be talking about the RDBMS. We will focus on that part because that is a part of the syllabus. Now we have already talked about the basic about that why we need a database. Here, in more technical aspects, I'll be talking about that why we need a database. We need database because we want to manage the large amount of data. We need database because we want that information which you want to store should be accurate. Okay. Accurate means the information which you want to store should be properly validated, and that way, when the information is properly validated, the information which will be stored within a database will be accurate. For example, your name cannot contain digits. You can't say, Aman 8. You can't say like that, right? So if user tries to enter that information within the database, it should check, and that checking is not known as the validation. Okay, so that information is validated, and only the accurate data will be stored in the database. So that is why we need the database, because internally it has got a check, and then only it will allow you to enter that information into the database. We need database because we want that information to be uploaded in an easier manner. All the interfaces which you see, that gives you an easier approach to store information into the database. For example, your Google form, while submitting your answers through the Google form, that Google form is nothing but the interface, right? And internally, it uses Microsoft Excel to store that information, right? So that Excel is the database in that case, because we are storing information through the interface, that is the Google form, and it stores information into the Google Excel sheet, right? So ease to data upload. That is why we need a database. We need database also so that the data remains secure, right? We have got plenty of databases which provides you the data security. So that means if one intends to deal with the data, that has to go through with those level of security, which is basically been provided by that application. So data security is there. We have got Oracle, that is an RDBMS. It has got 7 level of securities. So we have got network security, then we have got system security, and then we have got database security. So with these, security level, one has to deal, and then only the person will be able to deal with the data, right? So, so that is why we store information in database, because one has to go through with these many level of securities. We need database because we want information to be, or data to be integrated. Data integrity is nothing but basically the validity of the data or the consistency of the data. That means once you try to enter information to the database, and if it is able to store that information there, that means it's not like that. Next time you try to store that information, and it basically discards that. So if the information is able to be stored once, that has to give you that sort of process in which you will be able to store information to the database consistently, right? Second thing, either the entire information which you are trying to store should be stored, or if you want to delete, entire information should be deleted. It's not like that. If you are trying to store 100 information, it is accepting only 10, not the rest of the 90s. Or you want to update 100, it is only able to provide you those 10 or 20 or 50 updation, and rest it has been discarded. So many things may happen. It may be, during that process, the data, the system may go, the system may crash, maybe power failure, maybe any reason. If that process discontinues, that means either it updates, deletes, or stores the entire information, or nothing will be stored or deleted or updated. And that way the data integrity is maintained, right? That way the data integrity is maintained. Either it is called all or none property of the database. Either all information will be stored, will be deleted or updated, or none of the data will be stored or deleted or updated. And that way, basically, it maintains the data integrity. These are some databases which I was talking about. Oracle is one of them. MySQL will be dealing with, in class 12. We have got SQL Server. We have got Sybase. These are the product of Microsoft. And this is Oracle is an organization which has got Oracle application. And Sybase is again an organization which has got Sybase application. Other than that, we have got MS Access again by Microsoft. We have got Informix. We have got various others. Applications which are basically been given nowadays, right? That is again the need of the organization or the client, which database we will prefer to go ahead, right? That depends upon totally between the client and the service provider. Now the next one is MySQL and SQL, because we are talking about the databases. So MySQL is the database which we'll be using. In more precise terms, it's RDBMS, but we'll be keeping talking about databases, right? So database, that we'll be using, that is MySQL, right? And SQL is structured query language. MySQL is an application, right? And SQL is structured query language. SQL is structured query language. This SQL is common to all the RDBMSs, whatever you use. That means if you're using MySQL or Oracle or Sybase or SQL Server or MS Access, all these uses SQL, but the way SQL is used is different based on different applications. Otherwise, more or less 90 to 95% the SQL commands are written exactly in the same manner. The way we execute, right? The way we use these commands in application may be different. Otherwise, structured query language is exactly the same. And believe me, this is much more easier than the Python, because in this case, it's more relevant to the English language, the way we speak. For example, I want to create a table. So the command is create table. I want to create a database. The command is create database. I want to display the information. To display, we have got a command called select. Select what information you want to display. You want to display all. It says select all from the table. So this is comparatively much more easier than the Python, right? So SQL is structured query language. Structured means the commands are already structured. They are all defined. You just need to make use of them. Some of you might have used HTML, and HTML is hypertext markup language. There, the commands, the tags are predefined, right? And you can only make use of them. HTML doesn't give you that option to modify the command. If you want to, break the line, the BR tag is there. If you want to, create a body, then body tag is there. So the tags are already defined. You just need to make use of that. Similarly, in SQL, the commands are predefined. You need to simply make use of them. But to use SQL commands is very easy. To write SQL command is very easy. These are some examples of RDBMS which I was already talking about. So in generalized manner, SQL is structured query language. Structured means already defined commands. Query means to request to the server for information, and language, we already know it's a mode of communication. So overall, if you talk about to define the SQL is a way to request to the server for information, or we communicate to server to request for the information through already defined command. Okay, that is how you can define SQL. It's a mode of communication. In other words, if you want to write it down, you can write it down. It's a mode of communication to request for information to the server through already defined command. That is what SQL is. I hope you understand that. If anytime you feel you want, to know something else about this, you can always, give your question on group. I'll answer that question. Then database, we have already talked about. It's a collection of tables, right? Related tables. Table is a collection of related records, and a record is a collection of related data. And data is raw facts and figures. We have already talked about that. Then this is an example of your database. Database can be like, like this. We have got student management system. Similarly, library management system, railway reservation system. So many systems. These all are the databases. We need to create them, right? And within this, we have got these tables, and all these tables are related to each other. And that is why we say it's a relational database management system. Student is a table containing admission number, your name, father name, mother's name, date of birth, and so many other information. Teacher, teacher ID, teacher name, and so many other information. Similarly, stream table has got stream ID and stream name. For example, science, commerce, and humanities, right? So that science has got, some stream ID defined by the school, right? Suppose S1 science, S2 commerce, S3 humanities. Similarly, fee details, admission numbers, and fee details may be on a monthly basis, quarterly basis, or yearly basis. And later on, when we retrieve information from these tables, the information is collectively picked up and pasted on a designated place on a report card, and you see your report card, as a processed information. Then there's a broader view that we have got the database as the outer block, right? And this outer block has got multiple tables, and all these tables are related to each other, right? So all these tables are internally connected. I'll through the commands, obviously, right? All these tables will be connected and will generate a report for you. That is why we need a database. I hope this entire part is clear. This is the actual view of table, right? And you might have used in various parts of your life. Maybe you talk about the physics experiment, chemistry experiments, right? Serial number, name of the experiment. Then you have got the different readings of that experiment. On a daily basis, you need to specify the date. On this date, you did this experiment and so on. That becomes the table, right? In this case, we've got student table has got admission number, name, father name, mother name, and date of birth, and so many other things, right? And later on, we'll be talking about how you create these tables. Table is a smaller part which is basically been contained in the database. So we need to create the database first, and then we create the table. These are the I mean, in these tables, when you talk about it, these are the informations which you normally store, the data which we store. So, admission number has got certain types, like, the integer, name has got string, father's name has got string, mother's name has got string, date of birth has got date. So each and every field, these are called fields or the attributes. These are called fields or column or attributes. These are called rows. Okay. This admission number, which I'm talking about right now, this is field or column or attribute, right? And collectively, when you store information like this becomes a record. Independently, these are data. When you collect it, that becomes the record or information. Okay. These are called rows or records or tuples in terms of relational database management terminologies. This is called tuple or record or row. This is called attribute or field or column. Okay. This is called attribute or field or column. This is called tuple or row or record. So moving ahead now, the data type which are basically supported by the SQL, and which are the data types which are going to use in class 12th. We use int. Okay, we use int. We use decimal. We use numeric. We use char and varchar. We use char and varchar, right? And we'll be talking about the difference between these later on. We use date time. We use date. We use time. Okay, so these are the data types which are generally used in MySQL at grade 12th. So these are for the numbers, right? Because numbers contains your integers and decimals, right? This is for the string. Here in SQL, we use char or varchar. And for the date, your date of birth, your date of joining, the date of purchase, date of delivery, we use date data type. Date data type has got date and time also. Uh, then we'll be talking about types of SQL commands, which we have, which is very, very important to know, because these are the commands which you are going to use in your MySQL. We have got four types of SQL commands. और ये कई बार आपके एग्जाम में भी आता है that they give you like a few commands and you need to segregate it. Which one is DDL, which one is DML. For example, I used to give you the operators and you need to segregate it. Which one is membership operator, which is relational operator. Similarly here, you will be given the commands and you need to segregate it. Which one is DDL, which one is DML, right? So we have got DDL, that is called data definition language. That is called data definition language. Data definition language. This is data manipulation language. This one is known as data manipulation language. This is data control language, the third one, data control language. And this is transaction control language. Transaction control language. Now within DDL, we need to study create table, alter table, drop table, rename table, truncate table. Comment is not a part of your syllabus. So these are the commands which you need to study in your syllabus. Within DML, we need to study select, insert, delete, and update. That's all. In these four commands you need to study in class 12. DCL and TCL are not a part of your syllabus, but still you need to know a bit about grant, revoke. Sometimes the questions from these are basically being asked in your Viva, right? So that will give you an edge. I'll be talking about the commit, rollback, these two commands also, right? Just for the sake of your knowledge only, right? Otherwise, these are not a part of the syllabus. So only the command which you need to study in class 12th will be this only. And within this, we have got these many commands. These you need to study it for at least knowledge purpose. Now I'll show you how you create a database, because now you have got basic information about the database. So I'll be talking about how you can create databases, how you can create database, how you can create tables, and so on, right? So MySQL is the application which you need to install in a system, right? It will ask you to specify the password. And once you specify the password, it will show you the MySQL prompt. This is called MySQL prompt, right? And here you need to, write all the commands which we have got in our syllabus. Now, the first thing I want to know what exactly, what are the commands, what are the databases which are available in our system, right? So we have got show databases. See, I want to show the databases, and we have got a command called show databases. It will give me all the databases available within the system. You can clearly see these are the databases available in my system, right? Okay, so if you haven't, created the database, it will not show you anything. Otherwise, if you've created the database, it will simply give you the information of the database. These are the list of the databases which we have got within the system, right? Now, I want to create a database, right? So for that, we have got a command called create database, right? Create database, and you need to specify a unique name, because this is again an identifier. You need to specify a unique name, right? That is not in this particular system. So if I specify any name which is there in the system, for example, if I say DB1, which is already there, I guess, right? So it will simply show you an error that can't create the database DB1 because the database already exists, right? So we have got database up to 9. 10 is also there. Up to 12 is there, right? So we can start at 20. 20 is already there. 30 I can start, or 40 I can start. Any name, right? So if I say create, now, because we have already written the name, written the command, so there's no need to retype again. You can make use of up and down arrow key, which will display you all the command which you have executed in this particular session till date, till time. Sorry, we have used only two commands: show databases and create database. Right? It will show me. I'm just making use of up and down arrow key. Right now, up key will give me all the commands which I've executed till starting from the session we have started. So we have only two commands. You can see up and down arrow. Okay, up arrow will give you the command previously executed, and down arrow also will give me the commands which we have used till time. So only two commands are basically been used. So this will only show you two commands. Create database has already been used. So I mean, there's no need to retype the command again. It will already display you the command which you have already executed. So suppose create database db40, that is not there. So now it will simply create the database. You can see query OK. One row executed 0.0 second. This is the time, you need not to focus on that part, but still, you should know what exactly this is. The system has executed this command in just 0.06 second. Query OK means there's no error in the command. Okay. And one row affected means one statement gets executed in this. So database has been created in this, right? Now, if you, again use the command called show databases, it will show you DB40 in the list. You can see here, we have got DB40 here. DB40, right? This is the database which we have created. Now, within this, DB40, within this DB40, I need to create a table. When you create the database, you need to enter into the database. You need to enter into the database. For that, you need to use command called use database, because you want to use the database now. So you'll say use db40. Okay, use db40. So it will simply let you inside the database, so that you can create the table. Database change. From the default, now it will, you are into the DB40 database. Okay. And if you want to know under which database you're working, you have got a command for that. Select database. Select database. Oh, the spelling. Select database. So select database, command will give you the current database in which you are working. You are working under DB40. Okay. For example, there's a database called test. If I say use test, okay, use test. So it is now showing the database change. Now, if I again say select database, you can see it is showing me now that I'm working now under the database called test. Okay. So again, I'll go with use DB40, right? The database change. And if I say select database, it will show you now. It will show me now the current database in which I'm working. Okay. And now within this database, I want to create a table. Within database, I want to create a table. So I have got a command for that. Create table. Suppose I want to create a table called EMP, or a student. Or a student. Okay, so create table student. See how easy this command is. Create table student. Within this, you can write it on the entire command in just one line, but this is a better manner, which I feel it's a more presentable. Create table student. Now within this, I have got admission number. Admission number is generally of integer type, so I'll say integer. Or if you want to restrict, because I know that admission number can be of 5 digits, so you can say int within bracket 5. It will restrict the user to go for maximum of 5 digits, comma, because each and every column need to be separated. So that separation must be there with the comma, right? Then I say name. Name either is of char type or var type. So char of 20, right? Suppose only two fields I want to create, right? After that, there's no separation. If I want to store the address also, then I need to specify the comma. Then I say address char of, suppose, 40. Then closing bracket and semicolon is the way how you execute this command. I click on this one. If there's no error, it will say query OK. It will say query OK, right? Now, within DB40, if I want to know how many table has been created, so I'll say show tables. It will show me one table which I have created within this database 40. Okay. If I want to know what exactly this table is containing, for that, because I want to display information from the student table, so I'll say select. Star means all. Star means all the fields.